back to the South Main Auto Channel. Today we got this 05 Hemi Dodge here. It's not a Hemi, it's just the 4.7. And it came in just for kind of a routine repair. Had to do an exhaust manifold on the passenger side. Bolts were all broke off in the head, of course. So we got that job done. The engine light was on. The guy wanted me to take a look at that. Had a misfire on cylinder number 1. You know, just this really light fish bite. Occasionally, it's kind of worse when it was cold. So I checked that out real quick, and you know, in the shop and in the field, this kind of was brought to my attention. So to diagnose these, coil unplug ignition, you don't even pull out the scope half the time. Just take the coil, swap it with another coil, look at your misfire counters. If the misfire moved, call the coil and move on. But we do that all too often, and it's kind of, you know, I kind of brought it to my own attention that sometimes we need to take the time, if we have the time, you know, to actually look at the failure, to look at the coil, to actually look at it with a scope, and it's a great opportunity to capture, you know, a known bad, you know, waveform on the scope, or a known bad, you know, second picture of the secondary ignition. You know, what's happening with this coil? Is it, you know, is it shorted out? Is it open? Is it, you know, just really what's going on? Did it fail on the primary side? You know, of the coil? Did it fail on the secondary side of the coil? Or, you know, really what happened? So I know it's a bad coil, and we're gonna just take a scope and we're gonna take a look at it and just kind of analyze that waveform a little bit and save that, because the reason that can be beneficial is, let's say we had a vehicle in and we could use our scope and we could get to the plug wires on a V6, and it's the back of the back of the cylinder. You know, can we just get that scope waveform and look at that and analyze it and actually know what it is? You know, what are we looking at here? You know, how did this thing fail? You know, particularly before we, you know, go and rip an intake off, and you know, particularly on coil on plug ignitions. You know, let's say you got a paddle probe and you can reach right back to that intake, and you're watching a secondary waveform and you're like, oh, you know, it's this or it's that. And a lot of times that can save us a lot of effort. You know, what kind of problem are we chasing down here? So I actually have a paddle probe, but we're not going to use it in this case. It doesn't work that well with this style coil. For whatever reason, I don't know. I'm going to try a different brand, because I haven't had it work that well with many type of coil on plugs. It works best on plug wires. So what we're going to do is pull the coil pack out. I saved these plug wires off Subarus, you know, a few known good ones, because they're extended reach. They work on just about anything. We'll stick it in the end of the coil pack. We'll use our inductive probe for the secondary ignition voltage. And we'll also stick a inductive amp clamp on the primary side to watch the primary current ramp and the secondary voltage at the same time. And I think we'll be able to see how a failure on the secondary side gets translated right back into the primary side, and we'll actually get to see that on the scope. So our problem coil is back here, number 7. It used to be number 1. It used to be up front here. And I took and, just for the heck of it, swapped it with number 7 back here, because it's kind of the easiest one to get to. And you know, like I said, that's always a quick and dirty thing we do, you know, in the shop. And sometimes it pays to slow down. I got to get a wrench. That nut underneath there is turning. You know, slow down a little bit and just have a good look at these. Get that crack loose. The bolt underneath of it was spinning. So here's our coil pack that has failed, or is failing. So I'm just going to take and pop the rubber end off from it, and we can stick, I mean, it just has you know, a spring down inside of it. We're just going to stick our Subaru plug wire on there, which fits quite well. It'll go down, it'll make contact, so there won't be any unintended gap there. You got to kind of be mindful of that the best you can, because you're going to see everything on your scope, any kind of, you know, unintended gaps. You know, perhaps, you know, if it's the gap in between the cap and the rotor, or, you know, there's any other gap anywhere else throughout the system. So we're just gonna plug this back in, give ourselves enough room to get our amp clamp around that, hopefully. So it's just a 2-wire coil. The transistor's inside the PCM. So we just got a power feed to this coil and then our trigger wire. So we'll take, oops, all wrapped up here. Whoa, hang on. Take our secondary lead here. We're just gonna hook that to our plug wire. We'll hook that to our scope when we get it. We'll hook this to a ground in case this wire was a short out. It won't fry our scope, hopefully. Make sure we're plugged in good. All right, get our amp clamp. Take our amp clamp here for our other channel. And we'll hook this on one of the wires, doesn't matter which one. Put that on our 20 amp setting. And now we'll get our scope. All right, so I got our scope, got our leads hooked up. Let's see, we're gonna go to a 4-channel lab scope. We'll get this all set up. So look at the head on this guy, just doing a YouTube video.
Uh-oh.
Ivan sneaks in the back door. So you wanna join us in showing?
Oh, all right. Oh,
we've got, you'll be proud of me. We got some scope action going on
man,
here.
this is like what, 1 pound?
Oh yeah, it's nice, isn't it?
Sweet. I'm jealous now.
Yeah, so I was just getting ready to show, just before you walked in, we've got this Dakota that has intermittent fish bite misfire.
All right.
And I've already told the viewers I know what the problem is because I did it like any other shop would do it. You swap coils, problem moves. You don't even bust out the scope.
What is this, like Caveman Diagnostics?
Caveman Diagnostics. Bug.
Swap coils.
Yep, so what I did is I was explaining the benefits of taking a scope, taking the time to look at a known bad,
Okay.
to identify a problem, to see what portion of the coil failed. Look at the primary current ramp, look at the secondary voltage,
Absolutely.
and look at the problem, see if you can capture it and learn from it, and perhaps just kind of save that in your memory bank. In the event that this was a V6 and you couldn't get to the back of the intake,
Okay.
if you had a paddle probe.
Stuff it in there.
Stuff it in there. What are you looking for? Are you looking for, primary problem? Is it, open in the secondary? Is it shorted? Just kind of get some direction. So
Okay.
I actually did. I think you've done this in previous videos. Subaru spark plug wire.
Oh yeah.
From the coil.
Yep. They make quality wire for sure.
Yep. So I pulled the coil out. I've got the spark plug wire hooked up
here.
Yep. So, and then I've got secondary probe on the wire. I've got current ramp hooked, or current clamp hooked to the primary wire.
Yep, doesn't matter which one.
Doesn't matter which one yet. And we're gonna fire it up. I'm getting a lot of noise here on channel, on my...
Do you have a peak detector on channel 2?
Yeah, the channel 2. Let me grab the camera here so people can see what we're talking about. Yep,
Ooh,
so
like soft touch.
the yellow channel is our current ramp, and that's all set up.
Let's see what's going on here.
I've got our the green channel there. That's our ignition probe, but I was getting a lot of noise on it.
So it's kind of intermittent, on and off.
Yeah, it is. And I unplugged the current ramp. I've moved the ground. I can't figure out where the heck it's picking that noise up.
So
from.
right now is the key on?
Is the key on, Hannah?
Yeah.
Key's on.
What if you turn the key off?
Still getting that
Interesting.
little flicker across there.
Yeah, I don't know.
So
Well,
yeah,
what if you turn peak detect off?
well, that's perfect. Yeah.
Oh, okay, so what if we do both? Yeah, so it's just picking up both of them.
Yeah, just picking up noise here somewhere's under the hood.
Maybe
Maybe it's my light. Is it the fluorescent light? No.
Yeah, it could be anything.
Oh yeah. I mean, you get this interference with the peak detect on. It's a little rough. So I was hoping we could capture this on, on the scope and see what the heck's going on here. So we'll get this set up. We'll get it fired up.
50 millisecond time base.
Yeah, that should work. And I got the I put a trigger on the current ramp.
Okay.
Engine's stone cold right now, so we'll just start it up. I noticed it worse idling in gear. Yeah, particularly when you started it up cold, like, you know, when I brought it in, you started out putting gear, it's like, meh,
Yep.
you know, just real intermittent, and, you know, not a complete dead miss, so it'll be interesting to see,
Okay.
you know, what we come across.
So we should see no good and bad.
Yeah, that's what I'm
Right.
hoping for, and that's what I was explaining, that, you know, you can catch, you know, what's it supposed to look like, and then what's it not supposed to look like. And maybe tell why, but, you know, with all this hash on there, I hope we can kind of decipher through this. All right, well, we got all the noise off the scope, and again, the channel 1 is gonna be our current ramp on the primary side, and channel 2 is gonna be the secondary ignition.
And just in case Snap-on's watching, how do we get the noise out the scope?
Oh yeah, what we had to do is just remove the scanner module from the back of the Varus, reinstall it and restart it, and it seemed to get rid of all the noise.
Clear up.
Yeah, we took the Varus outside, making sure it wasn't shop
Everything in the
noise,
shop, right.
and it wasn't. It just wouldn't go away. So maybe there's a poor connection back there, because on the new Varus Pro, the scope module is removable.
So this guy, yep.
Yep. So we just essentially took it out, put it back in, restarted it, and everything seems fine. So if that's the biggest problems we have, that's perfect.
Hey, yeah, that's not too bad.
So go ahead and start it up, Hannah, and put it in reverse. Just hold your foot on the brake.
That's enough data.
Stop it there. And I don't know if you guys can see this or not, because the engine's so big and there's so much rotating mass that just sitting here under the hood, it's really difficult to tell. So what we'll do, we'll just pop into the scan data. We'll look at the misfire counters so you guys can see at about the rate that this truck's actually misfiring.
So we're in the let's go to the engine menu. It's nice you don't have to mess with the keys, you know. I'm not used to that.
Oh yeah, you know, wireless, man.
I'm just curious if there's any misfire codes here.
Okay, so I told the viewers in the beginning that I had a cylinder 1 misfire. That I swapped the coil with 7.
1 and 7, so now we have a 7.
Yeah, and we can see that's proof right there.
Okay.
And we moved it to number 7.
Yep, so what do you want to do, data?
I think it's under system test, actually.
Test, okay.
Which cylinder is misfiring, I believe, is the PID.
Which cylinder is misfiring? That's exactly what it says.
So, and I have to admit, this is one feature that the Autel does not have. They don't have misfire counters for Chryslers. Yeah.
No way.
Yeah. Go ahead and start it, Hannah, and put it in reverse.
It doesn't look like it's picking up every misfire.
No, it's not. But
Just
kind of wanted to show the viewers at the rate at which it's misfiring.
What do you put in idle or park?
They put it in park, Hannah.
The rate's about the same.
Yeah, it's usually misfiring pretty good right there.
Yeah, pretty consistent.
Go back and analyze our scan data now.
Okay. All right, so here, channel 1, like Eric said, we have the primary current ramp, and then channel 2 is the secondary capacitive pickup. So this is an actual misfiring event. So what can we say about this waveform?
Well, I tell you what, why don't, if you can back that out just a little bit, just for the heck of it, look at a known good.
Okay, so should we start with a known good?
Yeah, just
right,
pop over to a known good. I should maybe in the event before that.
That's bad. That's also bad. Okay,
there we go. There's a good one. Yep. Just so we kind of have an idea, what things should look like, what you should expect to see.
All right, so here we have our classic current ramp and our secondary waveform, and you can clearly see the burn line right here, and we can even measure it, but just for kicks we can put in our cursors.
Now the burn line, just to clarify that in case somebody doesn't know, that is when the actual spark event is occurring. And when the spark's ionizing a gap, it's not necessarily the gap, across the spark plug, but this is when, all the energy is released from the coil and the spark is happening. This is the event that's happening,
So it's a 1 millisecond burn time, which is normal.
Yep.
Where you're looking for 1 to 2 milliseconds.
Yep, 1 to
there.
2 milliseconds, yep. Yeah, it's a real classic looking pattern there.
So that's a known good. So now let's go back to a misfire event, like right there, for example. Wish you could scroll a little faster here.
Yeah, the scroll speed is.
Or can we, how about this? Zoom. Now we can pick out our event.
Yeah, that one's
Zoom
bad.
in on there. All right. Oh, that's a good one.
Yeah, that's a good one.
Is that a good one? You can find it worse.
Yeah, there's worse.
So we're looking for a big spike like that one right there.
Yeah, I'll give that a go.
Oh yeah.
Classic.
Nice. So here they actually overlap, so it might be a little hard to see. We can do one channel at a time. So first on our current ramp, we see this huge oscillation when the spark is supposed to occur. Now,
Yep.
what could that mean, Eric?
Well, I guess the best thing to do is to break this down. So our current ramp on the primary side is when the primary side of the coil is being charged, so to speak, I guess for lack of a better term, and current builds up. The current is fully saturated. The transistor in the PCM,
Yep.
says fire.
Turn off.
And all of a sudden we have all this energy that is stored in the secondary side of the coil, and it's supposed to be relieved across the spark plug.
Exactly. What if it doesn't get relieved?
It comes back and tries to punch the primary coil in the face.
It's called mutual inductance, right? The
Yep,
primary and
yep.
the secondary are inductance between each other, so one can affect the other.
Yeah, and if we could zoom in on that more, you would see better definition of coil oscillations there. You'd see this pattern that just kind of build up and down, up.
Yeah,
and
we
then
can
kind
try, an even shorter time base, but
Yep.
it goes up, down, because that energy is not dissipated in the spark. It keeps oscillating in that, in the spark plug wire, trying to find somewhere to jump to.
Yep.
But for some reason, it doesn't jump.
Yep, it's got no place to go. So if you can kind of envision these two coils in the primary side and secondary side when it fires, just one pushing back, like you say, mutual inductance. They just I've always kind of visualized it as, I'm pushing back on the primary, this energy has no place to go, so we're going to shove it back into the primary side. And
exactly.
you get those massive coil oscillations.
And eventually the energy does get dissipated
That's
from the current flowing back and forth through, the 7 kilo ohm resistance of the secondary coil, and the coil just heats up. That's where the energy goes. Really.
Sure. Yeah. The coil gets super hot.
And you said that coil actually smelled like a burning.
Yeah. When I pulled it out, to swap it, of course you smell it. It's just kind of an old electronics thing. I'm like, oh man, this thing stinks. So yeah, you could tell that coil's running hot, or hotter than it should, to the point it started to kind of stink.
Okay. So we have to come up with a hypothesis. Why is that spark not finding a place to jump? Like where? So it's an open secondary circuit, right? That's what we're seeing here.
Well, I know it's not happening with a spark. It's not going across the spark plug, and we could see that on our secondary waveform there that we'll have a look at in a minute. There is no ionization going on at all.
Right. So that coil is trying to fire.
Yep. Coil's trying to fire, and it can't.
It can't.
Yep. So at this point, it could be determined that there is an open, and you'll get this same pattern with a let's say you had a spark plug wire. You're doing let's say you're doing a conventional distributor system, an open spark plug wire. This is a classic pattern when you say for an open circuit.
So say you hold the spark plug wire next to a metal engine block. You see the spark jump, and you keep moving it away, and eventually that spark won't be able to jump that gap anymore. And that's when you start seeing something like that. Right.
And I think Scanner Danner is always big on this. Grounding your spark plug wire, and you would think grounding it out, like, oh, that's got to be bad. If it's actually better than leaving it open.
Oh, absolutely.
Yeah, because if you leave this thing open, that coil is just getting red hot. And that's why it's important to do, if you're doing, cranking compression, in-cylinder pressure testing, either disable the coil or short it out to a ground.
Yeah, you don't want to leave an open secondary.
Yeah, because you can see the amount of energy. I mean, how many volts are you talking? You got what, 15?
It looks like 15 kV.
Yeah.
I'd expect a little higher, but
Yeah, it could be just that capture too. So, you're talking thousands and thousands and thousands of volts.
Yeah, it's looking for a place to go.
Yeah.
And at 40,000 volts, something's going to break down, either maybe the insulation inside the coil, the epoxy.
Yeah.
And once that breaks down, that coil's toast.
Yeah, coil's toast. So, as far as what has happened to this coil, I don't know. There's just maybe there's just really, really high resistance between the secondary and primary.
That was my first thought because we don't have any spark plug wires here.
Yeah.
Right.
So it's not a plug wire. We know it's not a plug.
Could it be? It's not a plug because you moved the coil, and the problem moved with the coil.
Yeah.
So the problem has to be inside the coil.
Yeah. But I guess it's fair to mention that a plug could be a problem, right?
It could be a problem.
So keep that in mind. Yeah.
Absolutely.
If it can't jump a spark across that plug because the plug is bad, same thing. You're going to get this open circuit. But in this case, we know the plug's fine because we moved it, moved with it, so it's with the coil.
I think in this case, like, how can you have an open circuit in the secondary in this single cylinder coil? It's not a waste spark system, right? So I think we might have to draw a little schematic just to kind of visualize where this open could be.
How it makes a continuous
exactly,
loop.
Yeah, how it makes a continuous loop, because it's not very clear just by thinking about it. It's like
time to go to the whiteboard.
Do you have a whiteboard, Eric?
Yeah, and I got a whole pack of new markers.
Oh man.
So this is the Selfman Auto whiteboard. We've never been over here before. I've got a brand new pack of markers.
And you don't mess around.
I don't mess around. Oh yeah. I got the mega pack, so we'll use red and blue. I'll quickly draw.
So you want to do primary and secondary?
Yep. So we'll do primary. So we're gonna have wire coming in. We'll do our primary, and this is going to be battery voltage in this wire, and this wire here we'll just do a generic switch.
Yep, perfect.
So, and this is the ECM. This is going to be, I'll just draw it generically as a switch. Hopefully you guys can see this. There's a switch, so that'd be like your points condenser.
Switch to ground.
Yeah,
right?
to ground. Yep.
You just draw that in a little.
Oh, yep. Sorry.
Ground. Christmas tree?
Oh man, yeah.
What's the official name of that?
That's our ground. Best I can do.
That's cool.
I've always wanted to use these markers in a video, I'm not gonna lie. Pretty excited about this. So then we have an iron core, typically.
Cool, yeah.
And then we have our secondary side.
That has a lot more windings.
A lot more wire.
So it multiplies the voltage by what?
Depends on number of windings.
If you have, just ballpark, if this is 400 and that's 40,000.
Okay.
So you step it up by what? Times 100?
100, yeah.
So 100 times more.
So then we come out here on our secondary side.
Now, so if this was a waste spark,
we would have a spark plug.
Yep.
And a spark plug.
And these would be connected.
That's right.
Right. So that would be pretty easy. But what if it's a single cylinder coil?
So what we have, I'm terrible at drawing. This is my feeble attempt at a spark plug. Look at this. Huh?
That's too fancy.
So we have the spark plug.
Okay. And that's grounded.
Yep. This is obviously grounded.
Okay.
And then here's where it's different than a conventional waste spark system.
What about that side?
So this side has to return back to your primary side, right?
Those are tied in, right?
Yep, these would have to be tied together. Yeah, I mean, that's the only thing that makes sense. Because when spark occurs.
So let's draw the current path.
Yep, here I don't want to take all the glory of the whiteboard.
All right.
You can feel free to draw there. Hopefully everybody's following. I'll kind of zoom in on this a little bit. Okay.
So what's the secondary current path?
The secondary current path is induced by the primary current path.
So it goes through the coil, right?
Yep.
Through the spark plug to ground.
Yep.
But how does it return to here?
Well, being that it's grounded, what's it grounded to? Engine block.
Engine block, yep.
So it would have to return through the engine block and back to the coil, probably through, obviously how we have it drawn, through the battery positive side of the coil.
Yeah. So it actually, the current goes right back through.
Back through.
And it's kind of counterintuitive. Like, you don't think, why would the secondary current go back through the battery feed?
Yeah, back to the battery feed, yep.
But that's what it does.
Yeah, because it can't go through the switch side.
Right, right.
That's momentary. Yep.
So, but it's only, if you think about it, what's this actual current? What's the value of the current? What, do you know what a ballpark secondary current is?
Oh, it's microamps, isn't it?
I think it's like milliamps. But
It's milliamps.
It's small, yeah.
It's small, yeah. That's why it doesn't blow your heart apart.
Yeah, less than 100 milliamps.
Yeah.
I mean, we could calculate it, but it's really small current, so you wouldn't even notice it on your current clamp, you know. But that's that. And in our case, we think there's an open somewhere in this whole.
Yeah. So to get if we remember what our primary, just looking at the primary, not even the secondary firing line.
Okay.
You know, it comes up, builds up, it comes off, and then we get
those huge
we got
oscillations
these
there.
huge oscillations. So that can be caused from that.
Yep. So the current would be oscillating then between here and. Well, and you know, wherever the break is, it's going to try to come in both sides, and it can't make a spark through that gap.
Yep, that's right. So that is a possibility. You know, again, a bad spark plug is a possibility.
Yep, it's a possibility, but we ruled that out because it moved with the coil.
Yep. And then I think it's fair to kind of keep in mind that all this stuff.
Yeah, exactly. That's important.
Yeah, that is all inside of our coil pack.
Yep, so these are the two wires, the small wires, and then
that's
you have
our connector.
your boot.
Yep.
And that's it.
Yep, yeah, spark plug being down here. So the way that we can get this waveform, or what we suspect, is that has happened right there.
Because the problem is internal to the coil.
Yep.
You know, we know this is fine, this is fine. The boot is, I mean, the spark has to go somewhere.
Yep. Yep.
There's only a little spring in here and it goes right to the spark plug.
Yeah, plus that's all hanging up outside the block now.
Yep.
Yep.
So I guess there could be potentially, you know, break either somewhere in here or between the primary and the secondary.
Yep, certainly.
So I think the test to validate that theory is to do an ohm check between, you know, the coil boot. So we draw our ohm meter between here and one of these wires, you know, here.
Yep. And in either one, that's redundant.
Yeah, because if you measure it here, you'll just add this resistance, which is like what, less than 1 ohm?
Less than 1 ohm, yep. So we can go do a quick coil check. We'll check the primary side, which we know is good.
Yep.
Then we'll measure the resistance on the secondary side. I've got a brand new coil over there, so we've got a known good.
Is it aftermarket?
Yep, of course.
So we should measure one of the original ones, a known good original one too, just to compare.
Just to see, yeah, because coils can be made differently. You know, different manufacturers.
Different characteristics.
Yep, I know. You know, like Wells, for example, they'll put a lot of, you know, technology and stuff in their coils to, you know, if this is common, to prevent this.
Okay.
You know, of course, if they want higher secondary voltage, you know, you've got more coil windings. So,
sure.
You know, so yeah, so this value, that's a good point. You know, that this value of the secondary side should be measured against a known good of the same brand.
Yes, because that's always a variable.
Yep, that could change manufacturer. Yeah, and that's going to dictate the output voltage.
Okay. So do you want to guess what your resistance is before you measure it?
On the bad one?
Yeah, on the bad one.
It's misfiring quite a bit. It's got to be near affinity. I mean, it's got to be in a mega ohm range. I'm thinking, yeah. I mean, it's got to be high.
Yeah.
So because you remember the class we took, they took like 15 spark plug wires, hooked them all together. To get the, you know, like this ridiculously high resistance value, just to prove that it didn't change the kV output of the coil.
Okay.
So in order for this to, you know, have this dead misfire, or, you know, almost dead misfire, it's got to be super high resistance, almost open circuit.
Yeah, I would guess, and also considering you smelled the burning, you know, internals, if there's a gap in here, we would measure infinite resistance, but that coil still has enough power to, you know, make a spark right across that gap.
Yeah. Or there could be some carbon tracking that it's, blazing across.
Exactly, it's just blazing across, and that the spark is hot.
Yeah.
It's melting your whatever's inside of there.
Yeah. Yeah, I don't know. So let's go.
All right, man, let's go grab the ohm meter, which is rarely used.
Yeah.
But in this case, I think it'll come in handy.
All right, so we're done with the scope. And like I was mentioning in the beginning of the video, to save those waveforms, you know, save these, you know, these secondary waveforms, the primary waveforms of known bad coils, of known good, you know, cam crank sensors. Ivan and I we constantly share, you know, our data that we capture, because at some point it's gonna come in handy, particularly those cam crank correlations. I think anybody watching the Scanner Danner Premium channel right now, they know what's going on with that Jeep, and, you know, how valuable it is to have it.
Well, when are the next 2 parts coming out, you know?
I hope soon.
I've been waiting.
Yeah, I've been waiting too. So it's valuable. It's as valuable as having good tools as to have good waveform.
Yeah. Well, this thing is pretty slick. You know, Eric takes a waveform and he hits send on the email, and I get it instantly.
Yeah.
I was pretty impressed by that.
Yeah, yeah, that is a pretty cool feature. You know, to have the snap-on shop stream and be able to kind of go home and break down waveforms and look at them. Starting to sound like a geek. What'd you do tonight? Analyze the waveform. So we're gonna take out this number 1, which we know is good because we don't have misfires there anymore.
Okay.
And what I'll do before.
White paint saves the day, right?
Yeah. I don't want to we start messing around mixing these things up. So this is our
bad.
bad good. Ugh. All right, so you have the voltmeter.
Yeah, I got the ohm meter fired up.
All right.
All right, first let's measure the resistance of. Well, let's measure the primary first. Why not?
Okay, what are you on, the good or the bad?
This is the good. You didn't label it.
I didn't.
Okay, so measuring our leads, just to get a calibration value, 0.1 ohms. Okay. Now on the 2 pins in here.
This is the primary side.
Primary 0.8. Okay, that's fine. And now let's go from whatever's in here to one of these pins.
Yeah, remember they're connected internally.
7.4 kilo ohms. And just to show, you can go to the other pin and it's the same number. 7.4 kilo ohms. Right there.
Yep, so use the decimal point as a comma in this case, so 7,400 and
sure,
whatever ohms. Mm-hmm. Yep, and that's our.
All right, here we go.
Here's the bad boy.
Here's the bad one.
Well, hopefully this proves our concept.
Yep. Otherwise, we can just delete it from the video.
Yeah, that's right. Yeah, and then make up some other crap. So you're on the primary side.
Primary is 0.8. Or is it 0.6? Okay, well, whatever. 0.1 of an ohm difference.
Here's the moment of truth, though.
52 kilo ohms.
Okay, so we got 52,000 ohms.
Yeah.
Okay.
And the no good was
7,000. Yeah. Okay. Whew. I was sweating this wasn't gonna.
I'm actually surprised. I thought it would be infinity.
Yeah. I thought it would be more open, personally. So yeah, 52,000, but that's quite a bit greater than 7,000.
Exactly. So.
You know, but who knows? That really could change, perhaps with temperature. You know, but it did seem to me that this thing misfired worse cold than it did warm.
Okay.
Yep. I tell you what, just for the heck of it, I got the new one right there on the toolbox. If you want to grab that.
Napa.
Yep, got one from Napa.
Made in Poland. That's sweet.
That's good stuff.
Okay.
None of that Chinese stuff.
Yeah. This should outlast the other ones then.
Yeah. So just for the heck of it, see how the aftermarket secondary compares to the OEM secondary. You know, see if these are built to OEM standards as they all claim to be.
Yep. Okay. So let's do primary. Ohm check here. 0.6. Oops, sorry.
Yep, 0.6.
Right there. No, from the secondary.
We had 7,000 something before, right?
Yep. So we got 7.4 on the other one. That's basically 7.0.
Yep. So 6.98 kilo ohms. So yep. So almost 7,000 ohms on that. So yeah, so pretty close to the OEM good one. Yeah.
Yeah, let's pop it in and maybe get a waveform on this one and
just kind of see what it looks like.
Yep.
Looking and knowing good.
Call it a fix.
All right, so we got everything hooked up exactly like we had it before, just with the new coil, current wrap, plug wire on there. Got the scope hooked up. Go ahead and start it up, Hannah. Just for the heck of it,
go ahead and pop back into the scan data.
Alright, so we can see that the misfires are all cleared up according to scan data. Let's get another confirmed piece of the puzzle.
Yeah, looks beautiful. Alright, so we have our waveform captured on the screen here. The current ramp looks beautiful. Secondary is nice and clean. You have your burn time right there. Again, we can measure it. It looks about the same as the known good did before.
Exactly.
So confirmed fix. The one thing I wanted to try here and maybe snap on, pay attention here. The old Eris, the one that I have, has a glitch when you have it on manual trigger. So we did manual trigger right now. The waveform is frozen, right? So what happens if we zoom out?
Well, technically it should save.
It should, save the waveform, right? Moment of truth here.
Yeah. Yeah.
Oh, it did.
Yeah, in this case it did.
Okay. Well, I guess on the older ones, it didn't. It just gave you a.
I think I've noted. Now, does that happen with you on every single time basis?
That's a good question.
Because
the ones I've tried it on.
Yeah. Okay. Because I've noticed that glitch myself on really long time basis.
Okay, like you're doing a cranking.
Yep. Exactly. Then you come out and you look.
Relative compression test.
Yep. Screen's frozen. Everything looks great. You go to zoom out and there's nothing there.
Yeah. Okay. So maybe it is just for longer time bases. Okay.
Yep, that's right.
But yeah. So yeah, looks perfect. So I think we're done with this truck.
Yep. That is a thing of beauty right there. All right, viewers, that's it. I don't think there's any more else that we can do on this. I hope that you understand coils a little bit at our people attempt to demonstrate that and how they fail and what it looks like on the scope when they fail and what type of failure it was, that you can see. Like I say, for the best part about this is if you look at this, you know it's bad. You already know what the problem is. So look at the scope data, store that, save that, and learn from that. And that way you can apply it in a situation where, this thing's a walk in the park to get to a coil. Yeah, this should have been out the door in 10 minutes. But I think this is really valuable data, just like when we share cam crank correlations and we share, mass airflow data and just, store as much data as you can on good stuff and bad stuff.
And in cases like this, it's always good in any situation to verify in as many ways as possible the same problem. Yeah. And we did the ohm check, which is, everyone has a voltmeter.
Yep.
So that, that definitely showed a problem. Then the scope showed a problem.
Yep.
It's plenty of methods here.
Yeah.
So.
And it's good to, it's good practice. It's good to keep your mind active and learning and to identify that failure. It just makes it easier. You got to trust me on that. It just makes it easier when you're looking at, we got this Trailblazer right here with a V8, which is awesome, I must say. Dude, the thing's got a 5.3 and a Trailblazer.
Once we get that fixed up, we'll take it for a test.
Yeah, and it's selectable four-wheel drive. You can put this thing in two-wheel drive. It's got to be a hoss.
Burnout machine. Looks a little slick right now. A little slush on the parking lot.
Oh yeah, we'll be able to burn this thing. No, we can't talk about that.
Never mind.
At any rate, so we've got this thing here with a misfire.
Sure.
Yeah, so yeah, got this Trailblazer right behind us. That's got a misfire in it. And, we might be able to take, you can take all this information that you've learned and, paddle probe going down through, you see that pattern, you're like, oh, I've seen that before.
That's coil's a coil. You can do that on any car,
Yep. Yeah, this isn't discriminate versus, for what make and model.
Common knowledge.
Yep, so, so that was kind of the purpose of this video, not so much to how to find a misfire in Dakota, but how to look at your data, kind of work it through your head, what's going on with it and why it's happening, so. But at any rate, thanks for watching. You can find us on Facebook and Google+. If you want to connect with us socially there. And subscribe to our channel if you haven't. Check out Ivan's channel. Glad he made the trip up.
This is like the New Year's special, right?
Yeah, it's going to be the Self-Made on New Year's special. So check out his channel. I'll put a link to that in the video and in the description box below. So you can find him and all his diagnostics videos he does down at Pine Hollow Diagnostics in State College, Pennsylvania. Yep. And just remember, viewers, if we can do it, you can do it. So thanks for watching.
All right, guys. Happy New Year.